Okay, so that last problem was way too easy for all my students are talented and gifted, right? So this one's definitely worthy, right? But really, it's pretty simple. You already know how to calculate accelerations on objects that have the force of gravity acting against them, right? And in the end, that's what we'll do. So you already know how to do that. Let me just show you step by step what to do here. The first step is to figure out what the masses are, okay? So the model rocket has a mass of 0.238 kilograms, 0.126 kilograms of which is fuel, right? So the trick here is that this mass is going to be this to begin with, and then this minus this to end with, okay? So the mass changes, and that's why we have two different accelerations. And this is true with like the moon rockets. The g-force would get more and more and more as the rocket lost mass, which is kind of cool. Okay, so the first thing is let's figure out what those masses are. So the initial mass of this thing is going to be 0.238 kilograms, because that's just what it says, right? And then the final mass, let's divide this screen up. I always love dividing this up. The final mass is going to be, 0.238 minus 0.126, and that's 0.112. Let me just double check that. 238 minus 0.126. Yeah, okay, I'm spacing enough kilograms, right? So this is the final mass, that's the initial mass. And that devilry was subtraction. Okay, the next thing to do, I feel like, is that we should figure out what the thrust of the rocket engine is. So force times time is mass delta V. And by the way, this is where most of the mistakes occur. Okay, so let's plug the numbers into that. Let's see, force is what we're solving for. Notice that this is a kilograms per second question. Okay, so I'm going to have to plug in 1 second for the time. Just like that the first example, right, is equal to this mass, so 0.0184, right, times, and then this is our delta V for the exhaust gases, right? All right, and now we're set. So I'm going to go 0.0184 times 718, and I get that the thrust of the engine is 13.2112 newtons. Okay, so again, people mess this up. Now that's because there's so many masses, right? So you want to use, whatever you do for this has to be the mass of fuel burned, and this must be the time in which that fuel was burned. Okay, the delta V, nobody messes that up, but for some reason we mess this up. So just be careful. Do a bunch of these. Okay. So we've got that. So the last thing to do is to just simply solve the vertical acceleration problem, right? Okay, so the upward force is 13.2112. That's the thrust of the engine, right? The downward force, this is 0.238 kilograms, right? So the downward force is 0.238 times 9.81. Do you remember this? Does this sound familiar? That's 2.33. I'm just going to write 335. It's 33478, 2.33478 newtons, right? So that's this downward force is 2.335 newtons. And now we're all set. We're going to go, let's see, 13.2112 minus 2.335 equals 0.238 times A. All right, I can do this. Up arrow, I've got that, minus this guy, divided by 0.238. I'm getting 45.699. All right, all we have to do is solve this guy here. So that at the end, it's got this mass. So that changes it, right? So let's draw a picture. Same rocket, just not very much fuel, right? And the fuel, the mass of the fuel of a rocket is very significant. A well-designed rocket, most of the mass is fuel, 13.2112. Because, I mean, the other stuff is just dead weight, right? Okay, so let's see. This is 0.112 kilograms. So the force of gravity is 0.112 times 9.81 times 9.81. That's a little more than 1. That is 1.09872 approximately newtons, right? Okay, so this is 1.09872. And now we're set. Now we can go boop. We can go 13.2112 minus 1.09872 is equal to 0.112 times A. We can do this. I can do it. All right, where's my 13 number? There it is. 13.2112 minus that guy. I'm getting like 12.112 divided by 0.112. Badoomba. Okay, I'm getting my acceleration is 108.147 meters per second squared. And this is, I think this is data that I took off of like a big D engine rocket. This is why you shouldn't put live animals in an Estes rocket engine, because they can't withstand the force of this acceleration, right? This is like fully 10 Gs or something like that. That's 4.5 Gs. I think the limit for briefly might be 10 Gs or something like that for a human to survive. But anyway, 9 Gs, something like that. Sustained though, I think it's 4 Gs. Anyway, that's what you do. So step 1, figure out what those initial and final masses are, right? So subtract the fuel mass, right? Or figure that out. Sometimes it's harder. There are different problems. Figure out the thrust of the engine, and then just do it. You already know how to do this part, right? The force of gravity. You have to do it twice, once with the initial mass, right? And once with that final mass, okay? Happy hunting.